We have here 2x plus 1 all over x plus 2 cubed. All right, so the quantity of x plus 2 is meaning is cubed, first of all, and then that means we have 3 factors of x plus 2. So to set this rational expression up as a partial fraction, we will need to write a partial fraction for each exponent from 1 up to 3. So as we write this out, you're saying a over x plus 1, x plus 2 plus b over x plus 2 squared plus c over x plus 2 cubed. Okay, for each exponent from 1 up to that power. So then let's eliminate the denominator by finding the LCD. The LCD here is the quantity of x plus 2 cubed. So we're going to multiply that on both sides. So on the the left-hand side, the denominator and the LCD cancels out. We have 2x plus 1 equals 2. Here we go. We're taking an x plus 2 away from x plus 2 cubed. That's going to leave us with 2x plus 2. So you're saying a times x plus 2 squared. The next term, we're taking 2 out of 3 for the x plus 2's. That's going to leave us with b times x plus 2. And then for c, the denominator and the LCD cancels out. We're left with c. All right, so just as with the other example, we could use, if possible, the substituting the roots or zeros, um, substituting -2 in for x. Yes, it'll eliminate a and b to find c, but how would we find a and b? So this is where it would be easier to set this equation up as a system of linear equations. All right, so let's go ahead and set it up. But before we set it up, let's write this x plus 2 squared. Let's expand that. And that would give us, what? That's a good question. What will it give us? X squared plus 4x plus 4. That's what it would give us. Okay? So we have 2x plus 1 equals to ax squared plus 4ax squared, plus 4ax plus 4a. Then take the b and distribute. We have bx plus 2b, and then we have c. Let's combine our terms. We have our x squared term. We don't have anything to pair with that. We have our 4ax plus bx. That's our x term. Then we have our coefficients. We have 4a plus 2b plus c. Okay, so then our x term, we're going to factor out the x. This is our coefficient component. We don't need to factor out anything there. Let's just keep that as is. So 2x plus 1 equals to ax squared plus, let's factor out the x here. We have 4a plus b times x plus our coefficients, 4a plus 2b plus c. Now let's set up our linear system. On the left-hand side, do you have an x squared term? Yes or no? So when we say no, when we set up this equation, we don't have an x squared term, so we would say 0 is equal to, let's look at the coefficient in front of x, which is a. Look at your x terms. You have an x on the left side, you have an x term on the right side. The x, let's look at the coefficient. You have 2 is equal to 4a plus b. And then our constant here, I should say constant term instead of saying coefficients here. Our constant terms, we have 1 is equal to 4a plus 2b plus c. Okay, so here is our system. We have a is 0. Let's find b. You have 2 equals to 4a plus b. 2 is equal to 4 times 0 plus b. Therefore, b is 2. And then let's find c. We have 1 is equal to 4 times, let's write out the question. 1 is equal to 4 times 0 plus 2 times 2 plus c. Okay, and then we have 1 is equal to 4 plus c. That gives us negative 3. Okay. Any questions with what we have so far? No. So we have everything that we need. Let's go ahead and plug it back into our equation. And we have here, well, let's go ahead and write this out for a second. We have 0 over x plus 2 plus 2 over the quantity of x plus 2 squared plus negative 3 over the quantity of x plus 2 cubed. And because we have 0 over x plus 2, that's 0, our answer is 2 over x plus 2 squared and plus negative 3 over x plus 2 cubed. There we go.